This is the first problem of the Newton's application law. Imagine that you have an object hanging to the wall through three ropes. So we have three tensions, and we have also the force of mg acting on the object, the force of weight. Now you want to find the tensions in equilibrium. We have the mass equals 10 kilograms and acceleration equals 0. So we use this equation. The sum of the forces in the x direction is equal mass times acceleration. So the forces acting in the x direction is tension 1 and tension 2. So tension 1 minus tension 2, negative because it's going to the left, is equal 10, the mass, times 0, the acceleration. So tension 1 minus tension 2 is equal 0. Now you want to find the values of each tension. So we're going to use tension 1, we're going to use this graph or this diagram to find the components, component x of each tension, tension 1 and tension 2. So we're going to say that tension 1 is tension 1 cosine of 30, this line right here, minus tension 2 cosine of 10 is equal 0. Tension 1 cosine of 30 is equal to tension 2 cosine of 10 because we pass the tension 2 to the right to make it positive. So tension 2 is equal to tension 1 cosine of 30 divided by cosine of 10. Cosine of 30 is 0.866 and cosine of 10 is 0.985. So that gives us tension 1 is equal 0.879. Now we find the x component, but now we want to find the y components. So T1y plus T2y is equal mass times acceleration, which is equal to 0. So using this diagram again, the component of each tension in the y direction is using the opposite side to the angle, so we're going to use sine. So tension 1 sine of 30 plus tension 1 sine of 10 is equal 0. Now, the sine of 30 is 0.5 and the sine of 10 is 0.174. We use tension 1 0.5 plus we're gonna we have here the value of tension 2. So we're going, instead of tension 2, we're going to move this answer here. We're going to move this here. So tension 1 0.5 plus 0.879 tension 1 times the result of sine 10. So it's 0.174 is equal to 0. Now we multiply these two numbers that give us 0.153, and then we add these two numbers, so that gives us 0.653, tension 1 equals 0. We divide this by 0.653, that gives us tension 1 is 0 newtons. So the force of tension 1 that is acting on this object is 0 newtons. Now to find tension 2, we use this value that we find here, tension 1 times 0.879. So we substitute tension 1 times 0, so tension 2 is also 0 newtons. Now to find tension 3, use this. Tension 3 is going to be equal to the force of the weight, mg. So tension 3 is equal to mg, that is equal 10 times 9.8, the value of g, is equal to 98 newtons. So now we have the three values of each tension in equilibrium.